This meeting is being recorded.
We give a few minutes for some of the other folks to join, or would we want to get started?
Just to give us like couple more minutes so that people will get the context right from the beginning.
So we'll start in like another 4 minutes or so.
Oh yeah, sure.
Okay,
And
thank
I
you.
already made you as a host, Ananya. So please take over from here.
Sure thing. I'll make sure that everybody is on mute if they haven't, but if everybody can be on mute, which it seems like everybody is, that's good. Thank you.
Hello, Avani. I hope you are Avani Surendra. Am I right?
Now it's 5 minutes past the hour now, so we'll go ahead and get started. I'd like to thank everyone for joining today's Vrindavan with Tana network security and cloud security information session. And I'd really like to thank our guest speaker today, Mr. TL.Sharma from New Zealand, and appreciate for him to take time out of his day to come speak with us. Before I hand it over to our guest speaker, I would just like to really quickly cover the key parts of today's session, which are around network security and cloud security. And within network security, we'll be talking about firewalls, prevention systems, virtual private networks, access control, endpoint security, network segmentation, monitoring, and logging. And then within the cloud security, we'll be primarily focusing on data security, identity and access management, compliance and governance, cloud-specific threat protection, shared responsibility model, the secure APIs, and then the configuration management. One thing I would like for everyone to do in this call is to please be on mute. And the way we're going to structure discussion or questions in this call is by having people put in their question in the chat feature. And the first half will be our guest speaker talking about cloud security, network security, and the second half we open to the questions, which I will read off from the chat box. That way we will have ample time to answer questions and also be able to have everybody to post their question, not really interrupt or disturb when the first half of the discussion is being taken. And yeah, sorry, I probably didn't introduce myself, but my name is Ananya Maganti and I'll be the moderator for this class, and I want to hand it over to Mr. Sharma. Mr. Sharma, you might be on mute.
Are you all able to hear?
I can hear you now, yes.
Okay, let me share my screen. I'm trying to share my screen. Google Chrome would like to record this.
Let me give you that access 1 second.
Yeah.
Yep, I've gone ahead and made you co-host.
Share the
Let me know if
screen.
you're able to share.
Open enter screen window. Open system preferences. Okay, Chrome. It's asking some settings and give me
Sure.
1 second.
Yep, take your time.
Modify settings.
If you're not able to share, I can also share on my end as well. If that would be easier.
Maybe Ananya, can you make him as presenter so that he can share the screen?
Sorry, what was that?
Can you make TL.Sharma as a presenter so that at least he can share the screen?
Yeah, I mean, when he is co-host or host, he should be able to share the screen, but I can pull up the presentation if that's okay with him. But yeah, yeah, because I've made him co-host, so
Yeah, that should be okay. What about you, Sharma? You can share the presentation. Maybe you can talk. Once you have the control, well, I think something is coming.
yep. Can you guys see my screen?
Yes, I can see the screen.
Okay, sounds good. Mr. Sharma, are you there? You might be on mute.
Hi, good morning, all.
Hi, are you able to hear me now?
Yes, we can hear you now.
Yeah, sorry about that. I think Google Chrome restarted, it seems like. Yeah. Hi, all. My name is TL.Sharma. Everyone calls me Lakshmi Sharma here in Wellington. So, brief about me is like I'm working as a solution architect for one of the major operator here in Wellington, in New Zealand. So, let's try. I want to jump into the topic because the topic wide of the topic, and the time is a very tight timeline. So want to jump into the topic straight away. Is it okay? Okay.
Yes, please go ahead.
Okay, so now this network security or cloud security, and these days, especially in these times, it's so many words and jargons and buzzwords are there. Before we go to any of those words, first we'll start at the fundamentals. So I prefer to start from the fundamentals, so that because here audience are different. I'm not sure what sort of audience are there, because the level of exposure is one to many is different. Like some may got basic, some may got advanced, some may got super advanced. But if we start from the fundamentals, then it is much easier to correlate or match what we are talking about. So I want to start from the fundamentals, so whoever knows, it's a recap, and whoever don't know, that's much better. Like they can start from there. So here I want to start from the network fundamentals, then go to the security fundamentals, then go to the cloud engineering. So that is the flow I would like to take it. So here, yeah, this model, OSI model, is going, it's almost there, more than half a century, like but what it is. So for example, if you want to learn any language, like whether it could be English or Spanish or Hindi or whatever language, the first we start from the alphabets, right? So I say, if we come to any networking and security, these are the alphabets for it. Like how we look at it, how to which technology is mapping to which layer. So that kind of, so here this very popular model and easy to understand. So if we usually we start from bottom to top, which is like physical layer, data layer, network layer, transport, session, presentation, and application layers. These are basic 7 types of layers. So when we come into the routing part, switching part, or any security or network protections, so we map with these layers. So I briefly go into the layers, what each layer do, so and how it relates to. Okay, let's go with the physical layer. So everyone knows, everyone is pretty clear with this one, physical layer. So it is there's so many standards are there in physical layer, but these days we mostly care about Ethernet and optical. These are the main interfaces today's world. Any other interface are obsolete, or very rare places we see, like R232, DB9, this kind of. But our focus is like Ethernet and optical when it comes to a cloud engineering or network wide deployments. So Ethernet and optical is the key layer when it comes to the physical. So if we look at it at security point of view, how we secure these layers. So in Ethernet, it's a physical, like RJ45 we call it as, or Cat5 cabling, Cat6 cabling, or an optical. It got TX, RX, multi-mode optics and single mode optics. So these are all physical. How we secure this physical. So everyone, it's a clear answer is like physically protect the environment. So lock it and secure it. So which means like in data centers, or any building premises. So these are pretty much the access cards are there, and security cameras, all this. So that is how at this level we think about the security, because it's a physical. So then when we go to the next layer, which is data link layer, this here we can do some protection here, some security point of view we can think here. So what this data link layer do? So from physical layer, the next step is the data link layer, where the MAC address is the key thing. So MAC address is a machine access control address. Yeah, MAC address, it is a unique address. So no two addresses are same, like it is like a fingerprint. So if you take a laptop or a server or any blades or any metal, if you take, if it got a physical interface like Ethernet, whether it can be a copper Ethernet or a fiber Ethernet, so it must have a MAC address which is already burned to the board, like, which means that MAC address is stable. Okay, here there are some appliances in the market, like in the technology, so where configurable MAC address, which means you can configure a MAC address that you want, but still there is a burn-in address is there, that the configured MAC address overrides the burn-in MAC address. So it comes with the burn-in MAC address that manufacturer writes onto the board. Then on top of it, you can configure in certain cases for some applications, but that is a different feature. But when it comes to MAC address, it is an identity of the hardware. So in data link layer, the layer 2 switching happens. What is layer 2 switching? Because L2 switching, commonly you listen this word L2 switching. So this L2 word came from this OSL layer model, because it belongs, it operates as a layer 2. Layer 2, if I go to a little background, like we call it a LAN, local area network. What is it? Name itself says local area network, which means within the building or within the house or within the office or within. But these days the LAN expanded over the WAN. So that concepts I'll come in the last two slides, but for now let's look at the LAN, so which is local area network, only locally it is. But here if it is a big organization or a big data center is like, then we need segmentation, like that's where the VLAN comes. So which means it is a segmentation, like one domain, layer 2 domain shouldn't talk to the other layer 2 domain, or if at all need to talk to, go via upper layer, which is layer 3. So some like that, when we do segmentation, it comes into the VLAN, and it's called the layer 2 switching. Actually, what is switching? Switching is nothing but uh, it only operates at layer 2 and within the LAN network. So for example, it works on broadcast basis. So if one machine want to talk to the other machine, it sends a broadcast signal to all the machines within that LAN domain. So then whatever the right system, that will respond back to the whoever request. So this is within, it's called a broadcast domain. They call it as a layer 2 in switching world. It is called a broadcast domain. To limit the broadcast domain, we have to segment the layer 2 network. Suppose, for example, if we connect all 100 200 machines to the one switch, and switch hardware is too little, then this can't handle the broadcasting, because it maintains a MAC table within the switch. Like if a packet comes, it looks into the MAC table, so which keeps the switch keeps the MAC table, so which MAC address belongs to which port. So this table it keeps, and then packet will forward it to the port accordingly. But if there are 100 of machines connected to one switch, and that switch is very small, then it can't handle. So in that case, what they do is, like VLAN 10, VLAN 20, VLAN 30, like that. Which means slicing the switch into small broadcast domains. So that is called L2 switching. So there the VLAN concept comes. In a VLAN, in a Ethernet packet. So in an Ethernet packet, there are bytes called VLAN, .1Q marking. So it is there are 3 bytes. So there are 3 bits are there. So which we can use to prioritize, like VLAN marking. So on the switches, we can prioritize the traffic. For example, whatever the pbit marking, so pbit marking 0 1 2 3 4 5 up to 6 it goes. So this pbit marking, for example, if we do pbit marking 3, for example, if we say that to the switch, this is my important traffic, so then it will give the priority over other traffic. Or we can write on the switches, on the layer 2 switches, we can write a rule saying that if this is my trusted domain, so for example, VLAN ID, if on the priority, the priority, if it is my trusted priority, okay, don't check anything, just forward. Suppose if it's an untrusted priority bit, which is like a priority bit 4, for example, if I configure like it's untrusted priority, then send to the firewall, or this kind of based on the p-bit marking, we can give preferential treatment to the packet. So that is where it all operates in the data link layer. So, and then, yeah, there are some other protocols are operating on this data link layer, which is like point-to-point protocols, PPPs. So these still in the market in some places. So to give you a real example, if anyone knows, in the olden days, so we dial up modems, like we used to dial, connect to the internet, and then it's so that is where the PPP, point-to-point protocol, it connects to the RAS, remote access server. Your modem connects to the RAS, and RAS and modem negotiates, and then a PPP session will be formed. It all operates at the data link layer. And obviously, ATMs and frame relays, these are all related to the optical world. So those are also operate in the data link layer. And there's another MPLS. This is one of the key thing. Yeah, some argue it works on layer 2, some argue it works on layer 3, but it is MPLS, multi-protocol label switching, what it is basically. So in olden days, we used to connect one network to other network using a cable. So if we want to have a full mesh between, for example, if there are 5 systems we need a full mesh. So we need so much cabling, so much, you have to put cable for each and every one. So it's a bit hard. 5, 10 is manageable, but if there are 100, how? So then MPLS has come. So MPLS uses IP layer and gives a mesh kind of connectivity between all the nodes. This is a typical little advanced topic. I'll come when further slides, but MPLS operates in data link layer. It is 2.5, like between data link layer and IP layer. That is MPLS.
Claim from SPK 830515110.
Give me 1 second. Yeah, and so here, if we come think into the security mind, okay, this is network technology mind. So let's go to the security mind. So how we secure this data link layer? So earlier we talk about physical layer, lock up and then secure it. So it's a physical security. But when it comes to the layer 2, MAC filtering. So this is what you see in a lot of the corporate buildings and things like that. It's a MAC filtering. So what they do is on the switch, they already feed. They when we configure the switch itself, we feed that these are the only MAC addresses we are interested. So, for example, the corporate got laptops. Say corporate received 100 laptops from the vendor. So they distribute to all the employees. So all those 100 laptops MAC address tables are with the admin, network admin. So they feed it. That's it. Only those 100 laptops can connect to that switch. No, nothing else. Done. So if any guest comes, it won't open the port, or it can't communicate. So like that, we can do MAC filtering. So if we want to, if I explain a little more in a design point of view, so they usually create VLAN 10, for example. It's all employees VLAN. So whoever connect the laptop with this MAC address, okay, it gives the IP address, and you can connect to the network. But so, for example, there is VLAN 20, which is a guest network. So anyone can connect. It will give the IP address, but it won't give access to any of the company or any of the rest of the network. It gives the IP address, but that IP address goes to the firewall. That's where screening happens. So who is this? What is they doing? And why they are connected? And all these details. Then, according to the corporate policies, it works. So that kind of designs are pretty common. So that's how we secure at layer 2. And STP. What is spanning tree? Oh, yeah. Spanning tree is something like I told you that this broadcast domain. Layer 2 is full of broadcast domain. So sometimes broadcast storms comes within the switch. When storm comes, so everything go freeze. All the ports go freeze. So that is why when a broadcast happens, so one port, the port which is sending data, can receive but shouldn't. So it operates in a way like loop prevention. Broadcast storm, where the loop happens, there it prevents the loop and shut the port, one of the port, and then remaining switches can work. So to prevent this kind of broadcasting storms, which is also part of security, so the STP implementations are there. And rate limitings, we can do rate limiting as well. This is also a security. But for example, if anybody want to come and blast the network, so yeah, they put the laptop or server or something onto the Ethernet port, and then send huge amount of data, like 1 Gbps or 2 Gbps, it depends on, and then that chokes the network. So rather than that, if we know what is the genuine use of that port, what is the genuine rate required to that port, we can implement that, on that port, only 2 Mbps or 10 Mbps. So that is one way of usually what happens is in a corporate worlds, suppose for example, let's take a AAA server. If a small company is there, they got a AAA server. So what it do, it takes the username, password, and grant the access. This kind of AAA happens. What is the typical traffic of AAA? So maybe 10 Mbps or 20 Mbps, not more. It is not a video server. It is not an audio server. So then we don't need any 100 mega or 1 gig port opening. So then what we do is, on the AAA server only we give 10 Mbps. That's all. So which means even network is compromised, but still your AAA won't compromise, because they can't put more than 10 Mbps data onto the server to choke the server. So this kind of security we can do at layer 2 level. So then let's move on to layer 3. This is the interesting layer. So when we talk about any networking, so in a bold term, if we say networking, so most of the things happens in this layer. Majority of the things happens in this layer. So that is where all the routing and switching gear, routing and switching hardware is usually referred as layer 2 or layer 3. So layer 2 means previous slide what we discussed. Layer 3 means this one. Some switches and routers are layer 2 and layer 3, both can do. Typically it depends on the hardware and processing power and the vendor, all these detail, all these matters. So whereas usually it's a low expensive devices, the switches are there, they only do layer 2 switching. But carrier grade or enterprise grade, they can do layer 2 and layer 3 switching as well. So I'll come to that point, how this layer 2 to layer 3 works. But in this layer, today's world, the main protocols we see on this layer are IP, version 4 and version 6. So pretty much most of the people know what is v4, and it's also there since long time. So but the addressing space is come to end, so that's why we come to v6. The advantage of the advantage between v4 and v6 gives you much wider address space compared to v4. There are configuration advantages. There are a few configuration advantages between v4 and v6. V6 is little easier to configure when it comes to link net addresses and system addresses, and so v6 got few advantages, but both are works pretty much same way. The subnetting and other routing point of view. So that's when it comes to IP, the routing is the key thing. What exactly routing is? So routing is nothing but sending traffic, telling one network to reach other network how how to reach other network, telling one network how to reach the other network. This is nothing but routing. So when network is a very bold term, like, network means it can be 5 computers can be in the network, or 5,000 computers can be in network. So it depends on all these protocols, what protocol we pick. There are so many protocols, maybe there are 14, 15, maybe more than that. But I will talk about the key ones. So which protocol to pick is depends on the design, basically, what sort of network we are designing. So if it is a small network, maybe a few tens, like 10, 20, 30 computers on one side and another 10, 20, 30 computers on the other side, on the other network. When I say computer, which means it comes to anything like, servers, or, applications, or whatever. So if we have that kind of quantity, RIP is fine, or static routing is also fine. What is static routing? I didn't put it on the slide, but static routing is nothing but telling, oh yeah, to reach this network, your next hop is this. What is next hop? So the directly connected interface. Sometimes if you use tunnels, IPsec tunnels, I'll discuss what is IPsec. So then the next hop. So to reach this network, your next hop is this. That we administratively feed into the router. That is called static routes. The same way, other way, on the other side network router, we'll say that to reach this side network, this is your gateway. So simple. So there is no, what is the advantages and disadvantages? Advantages, like, it's very easy, like, configuration is less than 10 minutes. And the disadvantage is, like, in case if any port fails or link fails, it won't detect. Like, it still thinks that other side network is available. It keeps sending the traffic, which goes to the black hole. Like, it won't go anywhere. So even operator don't know until unless someone calls and say that, oh, we are not able to reach the other side network, and do the troubleshooting, and then, oh, okay, this link is gone, so fix the link. So this kind of in static routing, this kind of discomfort is there. But it is, when it comes to a small size network, that's okay. But if it comes to the big size network, it's a little bit bigger, maybe thousands of computers are there. So then we can go with OSPF or ISIS. So OSPF, ISIS, these two protocols operates in a similar way, but it's just standards are, based on the standards. Some north side of the world, ISIS is popular. Other side of the world, OSPF is popular, but both can do the same job. But our industry encourage both protocols. So these protocols, what it do is, OSPF a very big subject, but I give you few key points there. OSPF works in a domain fashion. What is domain fashion? Is like, it will have its own. It's all OSPF operates on the advertisement basis. Every router advertises what it state to the designated router. So just assume like is a peer manager kind of. So that peer manager advertise to the regional manager advertise to the country manager. Kind of this kind of advertisements are very segmented. So that's where the OSPF operates. That's how OSPF operates. So but every router will have every router's status, like to reach certain network, what is my next hop and how to go there. So this is the OSPF operating model. And BGP is a TCP based. BGP is a different protocol, and border gateway protocols it's called. So it is one network give its state to the other network through a BGP update. So when the BGP peering happens between two networks, so all the one side network's status will be updated to the other side using a BGP session, which is established over a TCP protocol. So what is TCP? Will come in the next slides. And when it comes to a routing world, so using hardware routers is a bit old fashioned. I don't say old fashioned, still it's existing, but because it got its own value. So earlier days, routers means, it's a big, like, big cupboard kind of equipments. So these days, SDN came into the picture. What exactly SDN? Software defined network. So what it do? It exactly do the same thing that routers, hardware routers do, but elasticity is the key. What is elasticity? It is another buzzword, right? What is elasticity? Elasticity is nothing but it grows based on your need. Suppose if you need a small router, SDN spins a small router. It is nothing but a metal, like some kind of hardware metal, huge, with a huge processing power, with huge RAM and huge throughput. Yeah, that is the one of the key, the huge throughput interfaces. But if you need it, that much power, it spins that much instances. Otherwise, it operates at a normal level. So where high demand comes, then without uh, any I start. Sorry, I didn't check. Is all okay?
Yep, you can continue.
Okay, where we are? It's okay. Yeah. Mm, we are going with the SDN, right? So in SDN, so its elasticity is the key thing, because as so much evolution is happening in the world, so much new technology is coming into the world. Because in olden days, a router means router. That's all. It can do this much, this much, this much. Okay, this much throughput is this. These are the hardware. I think I've been muted. Is it okay to move on?
Yeah, we can hear you.
Okay, thank you. So, um, so in olden days, a router is fixed, like the throughput, capacity, everything is fixed. If we want to upgrade, we have to upgrade the hardware, and that's how. But in SDN world, it based on the demand. So it's all becomes a software routers. So what it happens is, like, it got a massive hardware. It's a metal, okay, with the processing power and RAM and hard disk and whatnot. So all those things, and the key thing, the difference between a server blades and the SDN, the main difference is the interfaces. Because in server you'll find very normal interfaces, like 1 gig, 2 gig, 3 gig, 4 gig, like that. But when it comes to SDN interfaces, it goes up to 10 gig, 20 gig, 40 gig. It's a lag, they call it a lag, link aggregation group, which means multiple ports can bunch together and make it. Suppose if there's a 20 gig port, 5 20 gig ports, they make 100 gig. So this kind of all spinnings we can do there. So the SDN is nothing but a massive hardware with massive RAM and things, but it depends if the network needs, it creates. Suppose they say that, okay, we want 10 routers, they put 10, but suddenly some Netflix or something, some new series has come, and so network is choking. So then SDN detects by itself, like, oh, because it takes the sampling, it takes the throughput measurements. So if it feels like, oh, okay, network is hitting 60% usage, 70% usage, anytime it goes to 100%, so then immediately it spins another 4 routers uh, using SDN. So that is the SDN concept. It's called SD-WAN or SDN. So same, similar. Different vendors use different way, but even Cisco, Juniper, Nokia, Ericsson, and all this, they have their own names, product names to it. So that is where the SDN concept. There's nothing, no difference between how the protocol operates, between hardware routers and SDN routers. Protocols, all these RAID, OSPF, ISS, BGP, MPLS, everything is same in hardware and SDN as well. But the SDN benefit is like it in elasticity, and then multicast. This also operates in this network layer. What is multicast? So multicast is nothing but, we only, it's like our Zoom call. So like, so all everyone join, one person is talking and all person is listening. So this is called multicast. Unicast means one-on-one. So yeah, if I call one person, that is unicast. If I call only group of people, that's multicast. If I talk to everybody, if I put, like Facebook Live or something, anybody can join, anybody can see, that is broadcast. So multicast, usually what happens is, IPTV or sports channels. So they use this multicast, using all these routers, where there are protocols called PIM protocols. PIM is one of the popular protocol in the multicast. So this is what happens in the network layer. So much happening. So when it comes to because on this layer itself, we can talk hours and hours, but yeah. But when it comes to the security mind, okay, this is network concepts. Let's come to the security mind. What is how to secure, whether it's a cloud engineering or it's a network engineering. So the security concepts are pretty straightforward. So IP security, we call IPsec. What is this IPsec tunnels? What is IPsec tunnels in the sense, using normal IP path, two ends, which the ends which you want to protect, the two ends will will create a secure path, which means it will have a normal IP. On top of it, you will have its own IP. So it's an IP over IP. So if you capture a packet, IPsec packet, and if you go through, it will have two IP addresses. One is the underlay, which is the normal one, which is belongs to the network. On top of it, it's an IPsec session, the session IP addresses. So in this tunnel, it won't be routed. It's one end to other end. It's a straight path. There's nothing in between to look at it. So there's nothing can come in between IPsec tunnel. So it is straight one hop from this end to the other end. And okay, then underlay, there's another IP address, which is a common, which is normal one. So how it's protecting? So the traffic is going within the IPsec tunnel will be encrypted using its own proprietary encryptions, because in IPsec tunnels will have its own certificates on the routers on the one end and the other end. So these certificates is always keep the session monitoring, like, so the data is encrypted over the IPsec tunnels. So that is one of the way we can secure. And then other thing is access list. All the routers, when I say router, yeah, it is also SDN, also cloud. So whatever, so router, whatever, the device that functions at layer 3, that is router. Simple. The routers, we can put access list, saying that, okay, I want to receive packets from only these networks. Anything deny, we can say allow, deny statements. These things we can do on the Unix servers as well. For example, because Unix servers acts as routers as well. Okay, so because why I'm saying is, maybe in the audience there may be some Unix gurus, so they know what I'm talking. So on the routers, we put IP addresses. Again, if it comes to subnet or host IP address, some put host IP address. If you put a host IP address, you are very much securing the network, because only that PC or server can talk to the network, because it's a /32, which is a host IP address. But if you put a subnet, again, subnet, so how wide you are opening the subnet? So are you putting /31 or /28 or /26 or /24 or /8 or /16? So it's all depends, like, it's a depends on the need, how wide you want to open the spectrum, like, the range. So like that, we put access list. In the access list, yeah, this is the IP address we are interested, or subnet we are interested, allow. This is we don't want, or deny anything. So when we put that, it is a fast point of your security, first point of security. Okay, if any other IP comes, it will be rejected or denied. Or we can do all sorts of, like we can do sampling, and some unknown traffic comes, we can do sampling, and then go to the deep packet inspection, DPI, and look at it. So why it came, what it came. So all these are all other things we can do. But access list is one of the key thing. And then firewalls. Okay, what firewalls do? Access, when everything is access list is doing, what firewalls do? It's yeah, the firewalls, what it do is, in a router, router got so much job to do. It's that hardware got so much job to do, like looking at the advertisements, and sort out the routing table, update to the other router, peer routers, and then look at the access list. It has to do so much things. So then on top of it, it has to do the access list as well. When packet comes, it has to look at the access list, accept or deny. All these things the router has to do, which is so much job. So then let's offload this access list job to some other hardware. So instead of giving all this job to router, let's do offload this job to the firewalls. That is where firewalls come into the picture. So firewall is a dedicated hardware.
Sharma, I don't mean to cut you up, but I know we're like 45 minutes past the hour. So I don't mean to condense, but I know you have some more slides left. So if you don't mind, I guess, summarizing some of the remaining slides so that we can get to the questions towards the end of the session.
Oh, yeah, no worries. Yeah, sure. So then, it's already there. What is firewalls, VPNs, DPI, deep packet inspection, QoS, quality of services. Yeah. So then, when it comes to the transport layer, TCP, UDP, here we can do, this is the main transport layer, where firewalls, port blocking, pretty much at this layer, we look at the port blocking. So, for example, if anybody want to hack the network or penetrate the network, they do the Nmap. What is Nmap? It scans through the network. If we connect a laptop to a Ethernet port and then run an Nmap, it hits all the computers or servers and see what ports are open and try to attack into that port. So that's why we do port blocking. So if we know what ports only interested, so for example, FTP, SCP, SNMP, and all these applications, we know the port numbers. Most of the applications comes with its own port numbers, radius or AAA, all this. So those ports we put it in the interested list, and rest all ports blocking list. So which means even anybody do Nmap, so only open ports are visible. So those ports again will link it to the trusted network. So DDoS attacks, pretty much, what is DDoS attacks? So usually happens at this layer, DDoS. If any port is open, for example, FTP is open, so they send FTP traffic in such a way that the server or router get choked, and then it collapse. So which means network down. So this kind of DDoS attacks happens. So if phishing also happens at this layer, because they send payload with transport, and then once it reaches the target, it opens the port, and that's where the vulnerability starts. So that's where it happens in the transport layer. So the next one is session layer. Yeah. So in session layer, again, IP is there, and because why I put IP is like here in session layer, L2TP, PPTP, SNMP, PAP, CHAPS. So these are all sessions. So L2TP, layer 2 tunnel protocol, it is pretty much similar to IPsec tunnel, which I explained earlier. So between 2 points, a layer 2 tunnel happens. So it is like a physical Ethernet link between 2 networks. So over on top of IP network. So that is where L2TP comes. So where LAC and LNS kind of concepts comes. So L2TP aggregation controller, LAC and LNS. These are, one side is LNS, one side is LAC. So between it there's an L2TP session. So PPTP is also same point-to-point transport protocol, and SNMP and PAP-CHAP, these are session layers. How you protect using password protect, because L2TP tunnel, if you want to establish a L2TP tunnel, the server LNS need to have a password authentication on the router or on the hardware, and the other side need to supply the same password. So this kind of password protection is there. And if it is an IPsec, hashing will be there. So the next one, okay, presentation application layers. This is everyone familiar with this. Any application. So I put only few examples as we know still using today, FTP, Telnet, HTTP, SMTP, DNS, and all this. So how we secure with hashing and encryption. So suppose FTP is without encryption, SFTP with encryption, Telnet without encryption, SSH with encryption, HTTP without encryption, HTTPS with encryption. So this encryption and hashing we can use, and client server certificates. Sometimes if it is a very, very critical server and it's a very, very critical application, then server will have its own certificate, and client has to match that certificate with the client certificate. So, and keychains, we use the keychains in certain applications. So that is how we protect present. And if we go to the next slide, so okay, here, overlay underlay concepts. So according to the OSI layer model, we talk about all this. So what is overlay underlay? So underlay is a normal IP network. On top of it, we build another network so that we use. So for example, if we take the MPLS, multi-protocol label switching, MPLS is very popular protocol. So underlay it uses IP network, normal routing, like so any OSPF routing or ISIS, it uses underlay. On top of it, it uses MPLS. Why we use it MPLS? To give mesh connectivity between all the routers with less links. It is a P node concept is there. PE means provider edge router. P means the core router. So provider edge router got 2 links with the P node. That's enough. It can have then we apply MPLS, then it will have connectivity, mesh connectivity with all the routers in the network. All it requires is two links. Even one link is fine, but second is as a standby. So if one goes, the one will come up. So that's why this MPLS is called as an overlay. Underlay is IP. So on top of it, VPNs are there. What is virtual private networks? It is a routing domain. Within one single routing segment, within a single router or hardware, we can slice it into multiple routers. That's called virtual routers. If that is in hardware point, if you look at a hardware point of view, it's a virtual router. If it is looking at a network point of view, it's a VPN. So then VPLSs are there. It's a VPLS. It's a LAN, but expanded over the WAN. So that is E-line, which is a line from single connectivity, single cable, like you can think like one Ethernet cable connected from one side of the globe to other side of the globe. So it's an E-line. So ELAN same, and VXLAN. VXLAN is it's more popular on the data centers. So how all this security point of view, how we protect all this. So we'll go to the next slide. Cloud protection framework. When we are designing any security for a cloud infrastructure or data centers or carrier grade operators or networks, so we do multi-layer authentication with OTPs. This is more popular. If you want to log in, you have to get the OTP and then join. So all this. So network slicing. What is network slicing? It's critical networks are on one domain, one network domain. Whether you use a VPN or use a virtual router, or critical applications are one slice, and next like that. If you normal traffic is on one slice, so like that you can slice the network, and between each slice you can apply firewalls, so that if one slice to other slice, if you want to, you have to go through the firewall. So this kind of network slicing you can do. And rate limiting with SLAs, as I said, like if we can guess like how much rate this port need. So apply that rate limiting so that at least network won't get choked if compromised somewhere. So with SLAs, like how much, if it reaches say 30%, 40%, 50%, we can set an alarm, like it raises an alarm into the alarm monitoring system, like this is reached 60, then we'll start looking at it, and then increase or decrease, we'll do that. And IP filtering, the same thing, and port filtering, and data encryption, and traffic monitoring. So there's traffic monitoring. A lot of cloud service providers, they do traffic monitoring, like is it going, the traffic, is it going as expected or not. So this always the monitoring and alarm system works behind. And intrusion detection with live data sampling. So yeah, it's a proactive approach to look at the packet. Like what they do is the sampling in the network, they put what they call probes. Yeah, they call probes. So they put a probes in the network wide different spots. That probe collect sampling packet and sends to the deep packet DPI server. So it's a deep packet inspection. What it does is it open the packets and sees and who is the sender, what sort of the data it got. Maybe some it is not, it only do the sampling. It won't mirror the whole traffic, but it only do the sampling. From that, they can assess the threats. If any unknown traffic comes or unwanted traffic comes, they can do remedies. They can start remedies. So usually attack starts at transport with payload attacks. So they send a payload packet to a server, or on the port which is open, and then it creates vulnerabilities. DDoS attacks, denial of service, we send and bombard the router or server with such a traffic, like it fell down. So kind of attacks are there. IP spoofing, like it poses like a trusted IP but not. So that kind of IP spoofings are there. And port intrusion, the same thing. Whatever port is open, they try to penetrate into that port. So that is why always we have to do a penetration testing. If any new application, new server comes, we have to do penetration testing, like what ports exactly are open. And hash breakdown with bots. These days, yeah, this is another cool one technique they are using, like worldwide bots they are installing to crack the hashes, because cracking hashes, it is quite difficult task, but one server or a couple of servers can't do. So that's why they are installing the bots to do that hash breakdowns. So those bots we need to monitor as part of our security framework. So I think this is the last slide, or did I put anything else? I think this is the one.
Yep, this is the last slide.
Okay, yes. So this is what I can share with you all. If you have any questions, yeah, feel free to ask.
Sharma sir, can you chime in a little bit more about the certs from a security standpoint?
Sorry?
The certificates, like certs.
Oh, okay. Certificates, in the client server applications, so the server will have a certificate. Certificate is nothing but a hashing algorithm. So different Bellman algorithm, Geck algorithm. So the different algorithms are there. I don't want to go into this too deep of what those algorithms. Even I'm not much clearer, because it is a completely different topic. But these algorithms, so this on the certificate, it will have a key with that algorithm, and the vendor or the server owner, whoever, so they supply the client side certificate, so that we have to install into the client application. And usually licenses also, for example, license is valid for 1 year, which means in the certificate it will have a code that only valid for 1 year. After 1 year it expires. So this, when we, because I observed this, because I troubleshooted, and in my career path, so I work with the radius servers. Most of the radius servers, they will have a client side certificate and server side certificate. These two need to be renewed periodically, and you have to install on both sides. So it will always check before opening the session, it always checks, yes, is it matching or not. It's basically an algorithm with a hashing mechanism. Is it answer your question?
Yes, sir. Thank you.
So how that endpoint security and network segmentation, what tools exactly you guys use, to protect that?
What tools? I can example, like if we do penetration testing, like on the server what are open, so usually we run nmap. And how nmap, with the nmap scanning, you will come to know what ports are open. And then if we want to do the spirent, there is a spirent device. We can use the spirent device and then put it onto the server and send the traffic, imix traffic. What is imix traffic? It is all sorts of permutations and combinations that exist in the world. So we take that template and put it on the Spirent. It's a test center. So Spirent is a device. So, and put it on the server and see the server performance, like up to what standard, 1 gig, 2 gig, 3 gig, 4 gig. Like we keep increasing the traffic and see where the server fell down, and then we'll mark it like this much traffic it can handle. So for that we use Spirent, some Spirent tool. And firewalls, FortiGate is there, Juniper is there, and Cisco, Pix, and even HP firewalls are there. So those are for firewalls. Yeah. Alarms, to raise the alarm, like utilization alarm. So on the port, it depends on the vendor. Cisco, they got their own monitoring tool. Juniper, it got their own monitoring tool. Nokia, it's got their monitoring tool. So it raised the alarm. So they have these days, especially when SDN is so popular, they come with a full suite of all these applications. Is that all asked questions or?
Yeah, that's good. That's good. I think the network, how does the network segmentation protects it? I think how does how it exactly works, network segmentation?
Okay, yeah, network in olden days, if usually operator or big networks, they have one flat network. So I'm talking about one flat network in the sense all their for example, typical business applications like authentication servers, billing servers, or all these monitoring tools, all these network along with employee network or customer, everything goes in the same network in olden days. But now this, with this segmentation, what happens is we are giving a priority. So one thing I missed to discuss here, there is a term called QoS. If you Google it, you will find it, quality of service. So it is DSCP marking. So using the DSCP marking, we can put a packet, IP packet, the priority, the way we put pbit marking on the LAN. So this the DSCP marking on the IP packet. So based on that marking, we can send to a premium network. So slicing, let's understand, we put it in a normal wording. So say, let's premium network and medium network and low priority networks, like that. If we segment, so based on that QoS marking, we can map to the network, which network you want, premium or medium or low. So premium in the sense, that traffic there won't be any delay, or there won't be any jitter or any lag on the traffic movement. So when it comes to medium, it's a medium way. Low priority means if network is available, then low priority traffic. Otherwise, it takes its own time. Kind of, this kind of network segmentation helps to keep the business traffic more priority and more robust compared to any other traffic. Suppose if any intrusion happens, it happens only in one network, so your business traffic still goes stable. So that is the advantage of network segmentation.
Thank you.
We had one question regarding what, if you can please go through switching, the concept of switching.
Concept of switching. Sorry, question again, please.
The
What?
question was if you can elaborate about switching.
All right. Yeah. Switching. Switching word, moreover, it belongs. That word can interpret into multiple technologies. So here, because the switching comes into the mobile technologies, mobile switching, PSTN switching, which is world phones PSTN switching, so and ATM switching, frame relay switching. So here, when I talk here in this context, switching means layer 2. So IP switching, I'm talking about IP and this network traffic switching. Because mobile switching is entirely different. That is different concept. So in the switching, the layer 2, the VLANs layer 2 operates on the switch. How it operates is it keeps the MAC address database. Like when we connect a port, laptop or whatever, so it sends a broadcast signal. So it is a broadcast signal. Any PC or any laptop, any server, anything, that is the same address it sends to. So it's a broadcast address. So then at that time, it sends its own MAC address as well. So when it sends its own MAC address, the switch keeps the database. So these are the MAC addresses came from, these are the port numbers. So port number and MAC address. The switch keeps the database. And then whenever any packet comes for that particular port, it switch the traffic easily. That is where the word switching has come. So it knows, in the packet, this is the sender, it is a receiver's MAC address. So this receiver MAC address is on this port. So send the packet to the. It won't do any broadcast anymore. Only once it happens, and it keeps the database. So that's the word came from switching. So is that explain your question?
Yep, that works. Thank you.
Thank you.
Yeah, how does that cloud specific threat protection, how it works? What do you guys use?
That's what in the last slide I said. Cloud protection. Cloud is very generic term in my perspective. So when it comes to any protection happens out of these 3 layers, out of these layers only. There's nothing other protections is there. It's all prevention. And even if they say deep packet inspection, for example, in cloud engineering, so DPI is one of the key concept. What does DPI do? So when in a cloud service, if a packet comes, they do the sampling and then open the packet. It's just like a Wireshark. If you put a Wireshark, it gives the whole data of what is the packet, what VLAN, what IP address, what port number, what is the hashing, what sort of things it's do. All it gives the full details, so that it goes on the live network, where if suppose your 10 gig of traffic is going on the wire, it do sampling, and immediately within microseconds it get full details if it's a trusted or not trusted. So this is kind of happens. But if you are very specific about what cloud, because cloud is a very generic term, but specific I can explain, but this is what happens in the cloud in the background.
For example, let's take an AWS, an application running on AWS. How we are going to set the security?
Yeah, I think how does that AWS application, how does that security works on threat protection or whatever?
Yeah.
Protection.
Suppose again, cloud AWS. Suppose if you spin a AWS server, for example, so real hardware is somewhere in the data center, and suppose you're using your AWS, you spin, say, a Unix machine there. Okay, now Unix machine you spin, and then what for we are using that Unix machine. So say, for example, you want to run a web server, right? So you put a web server. So here security, whether we are looking at a data center perspective or a user perspective. If it is a data center perspective, they need to validate what sort of they already segmentation is already happened there, because they use a virtual physical metal on top of it, virtual. So anything happens within the user's Unix system that doesn't affect their own data center, because it is already segmented there at an OS level. You got my?
Yeah, right, correct. But at the endpoint, that device level security, I think, there, if something happens and sends the wrong info or malicious info to server, they're the problem, right?
Yeah, so that is what, they got their own client side client server certificates, without that, or user authentication. Suppose if you we think like in AWS, if you put a username and password, is that enough? No. So it relates to your profile, like on the database server, you got your profile. So who is this user, and what profile he got, and what resources allocated, and all this, it matches, and accordingly it will generate a certificate, and that validates your session.
Yeah, right. Yeah. And does that goes under a shared responsibility model, or how does that shared responsibility model works?
Share responsibility. I'm not sure. I need to. What is share responsibility? It is different. What exactly, in a common term? Can you explain me what is shared responsibility? Is it AWS, Amazon responsibility, or user responsibility?
Yeah, right. Either it is application side issue, or the end user level issue, or the data center issue. I think whose whose responsibility is what? How do we determine that? I think, is it because of something in the network problem, or at the data center problem, or at the application level, or end user?
It depends on our subscription, basically. Even now we got Dockers, right? So an AWS, they may use different people use different names, but come to technology, it's pretty much same. So Dockers, in the Dockers, what they do is they have a same hardware on top of it, same same OS on top of it, same kernel on top of it, user specific containers. Okay, suppose if you have, if you lend a container. Okay, whether it's a container issue, if some application is not running, so you hire a container, and you install your application, and you try to do it, and it's not working. Say, let's say web server, it's not working. So how to, where the problem is? It's a container problem, or the kernel problem, or the OS or hardware, or your profile problem. It's quite hard to determine. So it could be anywhere. But the basic things first, usually what need to be happen is, in real time world, what need to be happen is, first you need to at the beginning of the installation, or beginning of the deployment, turn off all the security first on that particular session. I'm not talking about the whole thing. So on the particular session, and give it test, right? And if all goes, then start implementing security layer by layer by layer by layer. So because if we apply all the security in the first go itself, it's quite hard to troubleshoot in which layer the issue is coming up. Usually this is our practice, like, because if it's a new install and new deployment, then do step by step. So first, make sure the application is working in your demo environment, and deploy the same application. It should same instance deploy. It should work. If it is not working, turn off the security on the layer by layer, and make sure it's working, then implement. It is only for that session or that instance, not for the entire setup. So this is how the troubleshoot makes easy. Is that answer your question?
Yeah, that makes sense, definitely. But the container level, and I think container level, any security or any tools that you guys use?
No, because I'm not an OS guy basically.
Uh,
Yeah, it's usually OS guys, because if it's a network related, yes, I do. But if it is OS level, no. I do OS level up to Unix, but not up to the containers level. I only user level. My knowledge is up to user level, not the admin level on the containers.
Yeah, got it. Thank you.
Oh, cheers.
I think those were the last of our questions, and I know we went a little over time, but I would like to thank everybody that attended, unless
yeah, I
anybody
think
has
maybe
questions.
if you have a minute, maybe I would like to ask maybe the compliance, I think, on the compliance identity access anyway, and I think you guys either use something, for identity, identifying the people or identifying the user. But how about the compliance and governance? Anything that you guys use in your network or cloud security?
Complaints goes, yes, there, right? We have to. There is an obligation of SLAs, like so there are some government bodies and control bodies. They define what is the what sort of SLA is required for what sort of services. Like so for example, if any failure happens, how fast we can fix it, and any delays, network delays, and round trip times, latencies. These are all well defined in the document. Like we have to meet those SLAs. So otherwise, yeah, government body, control body comes into the picture and starts investigating, or start questioning. Like this kind of practice is already there in the network. Um, yeah, most of the countries they have, New Zealand, Australia, US, most of these countries, they have a governance body, so they define the latencies and SLAs. Usually they call it as SLAs. So network uptime, port uptime, router uptime, and so all this defined, that we follow. So pretty much testing goes in that direction. So if we design any solution, so then when it goes for testing, so then those are the SLAs they need to ensure it's meeting.
Yeah, are there anything also defined for the cloud also? Applications, cloud applications.
I'm not sure. Yes, yeah, I can tell in the network point of view, but cloud architecture point of view, I'm not gone into that deep. Yes, not yet. Definitely, it comes under a data center SLAs. Yeah, because its cloud is, again, it is very it is something different world. Cloud itself is cloud. We can't correlate with any real technology. Cloud is anyone. Microsoft cloud, Amazon cloud, Google cloud, Apple cloud. So cloud means, yeah, it is. But if we dissect the cloud word into a real um, um, example or real design, like, okay, this is the server and this is the OS, this is the container connected to, this is the interface and traveling to, this is the network and getting this is the IP. So when we do all these details, then we can. Otherwise, just cloud, it's quite hard.
Right. Okay, thank you. And if anybody has any other questions,